should be a video in progress and such. And so I will be reading some of Brozo's commentary. He's apparently going to do or present a new experiment eventually, where he's taken the experiment that basically did demonstrate the existence of free energy, conservation of momentum, and now he's going to prove that levers don't conserve momentum. So he's going to provide us absolute proof that any notion that there's any law that you have to conserve the momentum is absolute nonsense. All right. Yeah, obviously it's going to be a pile of shit. So I'll read some of that. Well, I guess I'll read it first, and then we'll just go to the board and explain why each part of what he says is crap. Frankly, it's just crap. There's nothing other than just crap. Crappy reasoning. Let's call it that. All right. So he's responding to Dispar's lab, who has posted some sort of, I don't know what kind of comment it is, frankly, psychological babble, and he's not getting it. He doesn't have any expertise, and yet he's acting as some judge or referee or I don't know, mediator, and as if he's somehow constructively contributing to the debate. And it's just sort of horseshit. But anyway, and he's doing it all in some sort of honest way when he's really not. But whatever, it doesn't matter. I mean, again, this isn't that complicated. All somebody has to say to show that they have any integrity at all is just simply admit that conventional physics is far from credentialed. I mean, they just make claims and they really don't have evidence. And in 350 fucking years, there should be evidence. If it takes 4 times more fuel to go twice as fast, they should be able to show us a videotape. It's not that much to ask for. So all of these experiments are intuitively crap. Okay, they just create, dualities. They create a dissonance. They create a problem where there's a contradiction. So we'll just get to that. Yes, the video you described, you are intending to make sounds reminiscent of my oldest video that kicked off the pushback against Gary's claims against Physics Girl. So, and so on 2 years ago. So he keeps bringing up this stupid Physics Girl experiment. And again, this experiment has been done. So we don't need this one to be done by anybody because it's already been done hundreds of times. And it's a reliable result. Okay, so where are we? Did I load the... No, I didn't load the comments. So I don't have to worry about getting rid of it. Let's see, what is here? Nothing is connected, so I better connect that, I suppose. Except it's not one of the choices. Huh. Oh, there it is. Alright, now we'll get rid of it. Alright, so, really simple experiment. Again, nobody is providing any kind of analysis. So nobody else will draw these simple little things and say, yes, you have one mass, all right, you combine it, okay, with another one mass, all right, so they stick to each other, all right, and so this one's going 10 velocity, all right, and then the combined object will be, okay, this will equal, and it comes out really, very little losses here. It comes out really close to exactly like this. You lose exactly half the velocity and you have twice the mass. That's the way Professor Lewin did it. That's the way, like I said, it's been done hundreds of times with kind of ticker tape devices in different ways. The way I like better is they just have this little 10-mile-an-hour one and they just drop an extra equal mass on top of it to create the twice as massive going half the velocity. All right. Now, somebody's going to look at this and say, okay, look, this has let's say 200 joules of energy when you do the calculation. That's what you started with. And this only has 100 joules. And physics girl says something really stupid. She shows tomatoes blowing up and other crap and just bullshit stuff, and says it's deformation. So the 100 joules, we're supposed to believe 100 joules of energy were lost, and because she thinks we have to conserve that, we have to explain where it went. So she says there was a bunch of deformation. Well, she's not going to show us any. And then a bunch of sounds were made, and a bunch of sparks or some other kind of crap. Heat. There's a bunch of heat made, a bunch of other stuff. Now, it doesn't happen in any of the, visually you don't see any of that in any of the experiments. There's no measurement of any of that. And when you think about it, okay, the fact is you have the same momentum here, the same MV, the same energy by Galileo's understanding, and Newton and Descartes. All right, the same MV here. So the argument is, what they're telling me I have to believe, and I shouldn't have any problem believing, is that somehow I made 100 joules of, you could even just say heat, all right, or deformation, or noise, or vibrations, right, all these little ideas. I made 100 joules worth of them, so to speak. Forget about the, whatever the units are. You could say 0.100 if you want. It doesn't really matter. And their argument is that somehow I did that using no momentum. So I didn't have to consume anything's energy from masses moving. So no mass had to move. And I made heat. And I bent the metal. And I made sounds. And, twisted things. Did all kinds of stuff. And I didn't have to use anything that actually had momentum. I didn't have to use a moving atom to create all that. That's what you're supposed to believe. That physics doesn't have a contradiction built into it. That there's nothing paradoxical. That I shouldn't be saying, well, that seems paradoxical. I lose almost zero momentum. I mean, it's almost zero. And yet, I made 100 joules worth of action. I sharpened knives. I did work. Yeah, work would be the word. I did work. Okay, and I used no momentum. So that's the theory he's defending, obnoxiously, as if only only a little kid could get this wrong. Only an idiot would think this doesn't make perfect sense. Of course it doesn't make perfect sense. It really does require an explanation. So if you're going to claim this is what happens in reality, all right, that this actually does lose 100 joules of energy. Now understand, the reason why they say this loses is because if they can do the experiment the opposite way, okay, that is if they can convert the 10-ton train, okay, the heavy thing, the 10 mass, well, the 2 mass in this case, to create no confusion, okay, going half the velocity, right, if they can do the conversion the other way, okay, and create a 1 mass, all right, doing the 10 velocity, they'll be making 100 joules of energy that they didn't start with in the momentum. So the momentum will be the same. That is, if you calculate how much mass is moving and just understand the velocity numbers are synonymous with that, in the sense that they're both contributors to the capacity of something to have an effect, that is weight. So I don't lose any weight, any pressure in the experiment. It compresses, they both compress the spring the same amount, and yet, okay, I have 100 extra joules of energy. So, I mean, obviously the down experiment's easy to do because changing a velocity in the negative direction is a lot easier than changing a velocity in the positive direction. But why would that intuitively make sense to anyone? That you could change the energy and not use any momentum. Always conserve the momentum, all right? Have a zero change in the momentum, and yet destroy energy or make energy. All right, so that's the context for how this started. So he keeps emphasizing it's something, this is about Physics Girl. It's just that Physics Girl said it more overtly than most of the other people who do the video. They just kind of avoid this nonsense. But she overtly said it. Look, it's 250 joules in that case, and it's only 125 when we're finished. Even though the momentum is exactly the same. We conserved the momentum, yet we lost half the kinetic energy. So we have the same momentum, we didn't use any momentum, and yet we somehow lost energy. We lost it to heat and deformation. These are all things you could call work. All right. So we did work and we didn't use any momentum. Now that's not supposed to bother somebody. A physicist isn't supposed to be bothered. That's perfectly understandable to physicists. Now I would argue that none of you people are very smart, so that's why you can't figure out that that's not perfectly understandable, that that's absolute babble. There's got to be some explanation. You've got to explain that. And now I could go into the gun example and the other examples, which I guess I will use eventually in this video, but we'll see how it goes. All right. My March 9th video, if I remember correctly, in 2001, with the thumbnail calling him a wanker, was comprised 4 versions of Gary's challenge to us. Every one of those versions of an experiment were all mechanically flawed as a theory of measuring energy. So yes, he has no knowledge of how you actually measure energy. He's a Sparky, and he doesn't know the difference between voltage and amperage, and of course wattage, which can all be compared, pretty much are synonymous with, okay, very much a synonym for mass would be your amperage, velocity, same V, would be your voltage, and wattage would be your energy, your joules of energy. 1 watt is in fact a joule of energy. I mean, it's that closely connected. And the Sparky, okay, didn't pay any attention to that. He measured the voltage. Maybe he measured the amperage, but he never measured the wattage. The wattage is the energy. Obviously, just measuring the velocity wouldn't do you any good in these experiments, and just measuring the mass wouldn't do you any good in these experiments. Alright. Where he had repeatedly demanded we show evidence. Yes, from the very beginning I've said there should be evidence, and you won't agree that there should already be evidence. Shouldn't need to, 400 years later, defend a theory that you've accepted. You should have produced evidence when you accepted the theory. You should have had evidence. And you certainly, in the 400 years since, should have been able to create some evidence. That the one mass at 2 the speed compresses a spring more, so that would have been a good one, right? So we still don't even have that simple experiment done well enough. He did it in one case, okay, where he claims he measured the velocities properly. And what did he get as a result? My prediction, which would have been the same compression of... No, my prediction was 2 to 1, I guess, right? I'm just trying to think of how he measured how far it compressed the spring. No, my prediction was the same amount. So the first thing did 12, and I was predicting 12, because it's the same momentum. Half the mass, twice the speed, same momentum, same spring compression. His prediction was 16 point something, and he got the answer of 14, right? So, he puts it in capital letters as if he has certainty regarding this when his own experiment was clearly a demonstration of the fact that his experiments suck, because he frankly got an impossibly wrong answer. It has to really be momentum or kinetic energy. It can't be whatever he's shoving in between those two. Alright. It certainly did, he says. So just, fuck this. Yeah. Alright. B, moves more marbles or anything else. It certainly did. So this is more lies. Okay. I had two different masses crashing into the same heavy steel staple. So the staple experiment, this stupid glued together staples, and he bangs something into them in this arbitrary manner, and then claims based on how much they, how much of a shape they make, that somehow this proves how much energy it has. I mean, it's almost, you'd say it's worse than the cracker experiment. It's so bad theoretically. And he keeps trying to resurrect this horse shit as if these experiments should impress somebody with any kind of mechanical intelligence. When obviously you've had any kind of mechanical intelligence, you'd say you don't measure something's energy by banging it into staples that are glued to each other. Alright. He didn't like that, LOL. Yeah, because what's the point of this? What are you trying to do? Are you trying to really validate a theory with legitimate evidence, or are you trying to do theater? Are you trying to do magic tricks? Paper rabbit out of the hat? Or the rabbit's made out of whatever, foam? Or, it's one of those Japanese origami rabbits? I mean, what the fuck game are you playing? Yeah, it's obviously incredibly stupid as an experiment. It really doesn't prove the case, and you don't have to do much analysis. And then even the other experiments that, well, they are a little bit hard to analyze in the sense that you really have to know some things. I didn't know, 5 years ago, I didn't realize that, oh yeah, friction really isn't even. I mean, I might have said that, yes, I have this impression that faster things don't have as much friction. So, no, I didn't really not know that. I mean, it was already, yes, it was my perception that the faster you go across a surface, the less contact you have with the surface and the less you can possibly lose to it per foot. So, yeah, I already knew that. So, yeah, but I never applied it to something like, well, somebody says, well, how far will something roll? Well, yeah, I didn't know 4-to-1 relationship because I didn't have an explicit definition of it. But clearly, this is Galilean physics, okay? This is really old logic. And it's really reliable logic, okay? I mean, he did it over and over again. It's well established as a fact. The 1-to-3 relationship, and it happens on the ground when you're using gravity as the source of the friction. Anyway, C, generates more electricity. I certainly did. So that's a lie, okay? You generated different voltages, and then you measured the voltages not by measuring also the amperages at those voltages, but you measured them just by saying it turned on a light or it didn't. So he takes something like even a diode or even an incandescent bulb, things that we know will not turn on, okay, they'll just absorb heat if you don't put in enough voltage. So they're voltage limited, and he doesn't even understand that concept. And he's supposed to be an electrician of some kind. I had two masses, fashion into small electrical impulse generator. So again, and yeah, Faraday would tell you the faster you move the magnet, the more voltage you'll get. The bigger the magnet, the more amperage you'll get. Did you account for any of that? Did you measure the actual wattage? No, you didn't. So, yeah, you didn't measure the energy. You measured the velocity and then pretended mass doesn't matter. So fuck you, more bullshit. You might call it, i.e., magnetized rod being pushed through a coil. And again, so go ahead and prove that the magnetized rod pushed through a coil doesn't have the 2-to-1 relationship. That is, if you double the velocity, you'll double the amount of energy or electricity you produce. Anyway, changing a capacitor with a meter indicating exactly double the voltage generated. So again, And voltage is all there is. There's no such thing as amperage, and there's no such thing as wattage. So does double the voltage mean double the wattage? No. Is it perfectly understandable that you could move a bigger magnet slower, and you could move a smaller magnet faster and create exactly the same amount of electricity? Yes, that's perfectly understandable by Faraday, 200-year-old physics. He didn't like that. Yeah, I don't like stupid experiments that just create noise and misimpression. You're lying to people if you're saying you measured the total energy produced by the objects, because you didn't do that, you fibber. Okay, anyway. He said, show me the lighter object crashing into a rope or lifting a horse with a pulley. Right, so this is another way of testing, okay, how much energy something has. So I already explained this years ago, okay, when he did this crappy experiment. But he keeps arguing as if he keeps trying to say these are valid experiments when I explained how, well, he did it wrong. So people have done, you can find these on the internet, where this is another way of attempting to measure energy. Now, I would argue that it's fundamentally subject to an argument about how, it's a little bit more, you might get more losses to friction, so it's not ideal. But again, I shouldn't have to explain this more than once to this particular individual, but it's just the idea that he keeps promoting his experiments as valid, having integrity, having quality, as something you can rely on, okay, as explained to you or showing you how the physics works. And they're fundamentally flawed. It's not a minor flaw. So the idea is you take a string, take a couple of pulleys, all right, and then you have a weight. All right, and the idea is you just plow something into the string. The energy will be absorbed as displacement of the string, you can understand. Now, there are problems with rotation, so you can understand some of the friction will pull on the string and different things. But the idea is pretty simple, that yes, you could displace this, that pulls on the string, and that will lift the object. Now, the problem with his experiment is this weighed, say, whatever, 2 masses, and this weighed 0.01 masses, okay, way too light. So obviously the spring was putting up very little resistance. The object pushes through, gives it the maximum velocity, and essentially just shoots the object up like you were lifting, like you were shooting something up with a lever almost. You're giving it extra velocity, that means you're doing the cheat where you're going 4 times the distance in gravity, and all you have to do is do twice the velocity. So again, you're breaking the rules of the mechanics, okay, by creating a jerk, an impulse, rather than measuring the actual lifting capacity. So you're right back to the argument where, well, yes, it's 4 times higher, but it's only twice the time, okay, twice the velocity, twice the weight. So instead of really lifting the weight, he jerked the weight. So it's like a weightlifter jerking the weight up and making it easier to lift the weight, because he used more velocity to escape the gravitational penalty. The slower you lift the weight, the more the gravitational penalty. The faster you can lift it, the less gravitational penalty. Its weight is based on how much gravity you're fighting. The less time you're fighting the gravity, the less work you actually have to do. So that was a fundamental flaw. This weight has to be at least as equal to this weight, or the experiment's going to be a pile of shit. Because this basically does a velocity conversion. This, like the lever, okay, ends up converting, okay, a velocity here into a faster velocity here. So he's essentially creating, you have a velocity going in of 20 miles an hour, you end up with a 40 mile an hour velocity up. That's not what you want to do. Alright, so it's a garbage experiment. You can see it in the video, he's using little plastic chess pieces, and you can see them flying up into space. You can see them lifting off. You can see the string not being taut anymore. So it's completely lost connection to putting tension against the movement because he's completely defeated the tension. There's no connection between the objects. It's like making something go very fast over a surface. It doesn't make contact anymore. Alright, so complete bullshit. Alright, D. He said, show me a lighter object crashing into a rope and lifting a horse with a pulley. So, not having a horse or an actual 10-ton, 5-ton train. So again, these are just analogies, metaphors, to experiments. So when I say 5-ton train, as I pointed out, it can be 5 ounces. Doesn't matter. It doesn't have to be 10 miles an hour. It can be, 10 meters an hour. It can be 10 meters a second. It doesn't matter. The ratio has always been the important part. The inverse mass to velocity ratio. See, I say inverse mass to velocity ratio, and real physicists, okay, remember that, whatever that asshole was, AI physics or A1 physics or something, whatever his name was, said, what does that mean? Yeah. Anyway, used in all his examples. Yes, it's just talking about conserving the momentum and switching the mass and velocity proportions of the momentum. So you have the same momentum and you just invert the mass and velocity. I made a pulley experiment using cotton spools, showing it lifting chess pieces representing a horse. Right. So he lifted objects lighter than the object causing the pressure. I had to use pawns as the knight was a bit too heavy. Yeah, too heavy to make it come out your way. Yeah, that's all. What do you mean too heavy? Too heavy for what? To create your fake results. Okay. And yes, it certainly did once more lift the horse higher. I don't even know what that means, but that's not very quantitative. I did other variations, but it was just laboring the point that he was clearly wrong in all these and other incarnations of the claim. So again, he just keeps claiming that these experiments aren't theoretically garbage, okay, based on false premises of how gravity works and how friction works. He doesn't understand either one at all, okay. That they would do absolutely identical amounts of work. So there's no evidence of any work being done. Let's see, how else can we put it? Again, he's going to argue that you can actually conserve momentum and lose hundreds of joules of energy. Okay, he's demanded to see it pumping more water, for instance. I haven't demanded anything. I suggested as an experiment that cylinders do exactly what levers do. And so I drew an example. No one's countered the example with any kind of logic at all, so I'll just do it again. Because how can you logically escape the conclusion? I don't see any logical escape, so if you could just provide the logical escape, I'd really appreciate it. So just show me how this isn't exactly true in terms of what will in fact happen if I make this simple device. So we have one cylinder here, okay, that pushes into a vessel with fluid in it, uncompressible. And I have two cylinders on this side of the same dimension. So they're the same size as this cylinder. Same volume displacement. Okay, and the simple argument is if I tie these two together, now I have the 2 mass, alright, and this would be a 1 mass. And the simple argument is that I could push on the 2 mass, and it will obligate, okay, whatever velocity I push with here, it will be obligated that this one move twice as fast, okay, this will have 2x the velocity. And if I do the inverse, I go in with this velocity, I'll get 1/2 the velocity here. and that there's really just no way to avoid that relationship. And I could make this 5 cylinders, I could make this 400 cylinders. And in a sense, I could recreate the bullet and the gun just like with the lever. Now, obviously, there's all kinds of mechanical reasons why I can't do those extremes. But the theoretical argument is there. The fact is that I can just keep increasing the number here, put a weight on it. And the fact is the weight will have to travel through all of this, and the pressure will be felt by this, and it will in fact have to move at twice or 4 times or 8 times or 12 times. You know, it'll have to move the distance that this moves. The displacement will have to show up over here. Now, what's the theoretical argument saying this won't happen? Okay, just explain to me why that won't happen. How this, okay, I push on here with, you know, whatever, 10 velocity, and I'm only going to get 10.4 here. You know, I guess I did that the wrong way. It would be 14, sorry. Right? Yeah, 14. Okay. So it's half the mass. I put in 10 velocity, and I'm going to get 14 here. So I don't get 20 miles an hour. I put in 10. It's going to be twice the displacement here, 2 cylinders. This one has to go. It has to move. It has to do the displacement. It's twice as much displacement, but it'll only be 1.4. And where will all the energy go? Are you going to say that it's going to get hot in here? What are you going to say where it went? Where did the momentum go? Where did the 0.6 disappear to? Where did it leak out of the experiment when I did it this way? And then when I do it the other way, okay, when I push this mass, okay, with the 20, and you say I'm only going to get, let's see, so when I do it the opposite direction, when I do it this way, it's 14. When I do it the opposite way, this will be 1.6. What will it be? It has to be half of it. So it has to be like 0.7 or something. But somehow this will only, no, that would be, yeah, that's the free energy, right? No, that's the losing energy. Going from the small thing to the big thing loses energy. Going from the big thing to the small thing gains energy. Right, so he's saying it's only going to be 1.4. So he's conserving the kinetic energy, but he's destroying the momentum. So we don't conserve momentum, but we do conserve kinetic energy. That's his argument. So no physicist says that. So isn't that another reason for me to doubt it? Professor Lewin I played the clip. Is there any counter argument from them explaining why Professor Lewin was wrong to say there's this rule about conserving momentum? That, you know, he actually says nature can finagle. I mean, nature can mush whatever kinetic energy one way or the other, but nature can't finagle momentum. Those are his words. But I mean, why won't this experiment work? How will this come out 1.4? How? And like I said, if I do it the other way, I can't. I didn't think. Anyway, I'm just saying that, you know, this way I'm losing momentum. This way I'm going to gain it. Because to keep to stop from losing if I conserve the kinetic energy going this way, I have to, okay, lose the momentum. I could have stated it more perfectly, but I'm just saying the mechanical rules I think you can understand. Okay, yeah, I shouldn't have to explain how it's really a simple device like the lever. How do I break it to satisfy their physics? How do I make it not work? You know, to create their fake physics. Alright. Guess we can put this up there, but I don't know how much value it has for you to even see the miles and miles of text. Okay. All right, he demanded to see the pumping water, for instance, lighting more light bulbs. That's right. I demanded that you should be able to provide, in the 350 years that this stupid theories existed, a bit of physical evidence showing me kinetic energy doing more work. You should show it. Okay. Show the bullet doing 2,000 joules of work, and the recoil of the gun only doing 2 joules of work. Show me that. It certainly did light one light bulb far brighter for longer. So again, it lit it with voltage. So that's exactly what you would expect. Okay. Although I had to video it in the dark to see the filament glow in both cases. A completely useless experiment. It was so unspecific, undetailed, unrigorous. Okay, just another show experiment. I'll create a bunch of noise and throw that into the middle of the conversation. Completely illegitimate in that he was never collecting the absolute wattage produced. That was just a little hand-cranked generator with built-in light bulb, an incandescent light bulb, a filament lamp, because those give a cleaner indication of the power is doubled. So again, he says the power is doubled, yet a filament is completely voltage dependent. Alright, LEDs have complications because they require a certain voltage before they turn on at all. So do filaments. Alright. Then came all the show me. There's no then came. That's been the argument for the very beginning. I read that there was this 1/2 mv squared, and I said, what the fuck? And then I went out to go find the show me. And there is no show me. Alright. An 8-pound bowling ball knocking down more pins than a 16-pound ball with at half the speed. So I did. So this is another one. This experiment was so garbage and rubbish. So again, it's just, I can't even compare it to the, pulling the origami rabbit out of the hat. He pulled potato salad out of the hat. I mean, it wasn't even, it wasn't even close to, doing a clinically reasonable experiment with very hard, heavy reels, 2-inch recording tape. So there's no way this was a measure of their velocity. So you're not measuring how much energy you're giving them because you're not hitting them directly. It's all a bunch of indirect consequential impacts. Tipping things over is a lot different than giving them great deals of momentum, and that's what the whole experiment is for, is to try to itemize exactly how much energy you're losing per impact. So it had nothing to do with that. Anyway, 2 masses are similar, knocking down bottles of water, and clearly the lighter one going faster knocked down more. And who would have argued otherwise, I guess? No, okay, so he's saying that somehow the lighter one in that case had more, wasn't doing the 1.4 thing. Somehow he did reliably give it a 2 velocity, but we don't know that. So anyway, but a completely useless experiment. Frankly, again, just crashing Matchbox cars into crackers. This is a silly idea. Alright. And on it went. Right, and on. You made really crappy experiments trying to shenanigan people into thinking there's some validity to this absolute horseshit crap. Like somehow you're going to fill in the gap in physics. So this is like doing the Eddington experiment with, a toilet paper roll or something with a couple of lenses in it, and saying you're going to measure something. It's pathetic. Alright. Him coming up with endless variations of his challenge. Well, because I didn't really expect people to do experiments in the silliest ways possible, so yes, I had to keep modifying the experiment to say, well, you can't do this and you can't do that. You have to use a quick release. Different things like that were realized, well, gee, you're really not paying any attention at all, are you? Alright, completely denying every time I did show him he was wrong already. So he did. To say that these experiments are good enough to convince a reasonable person is pathetic. I mean, it's so unreasonable. Alright, he just keeps reinventing the challenge. I keep searching for an experiment that can be done, okay, where you actually create a qualitative result that could be respected by a reasonable person. Okay. Even betting on something he has no intention of ever paying up on. So there's another one of his lies. I'll bet you whatever amount, okay, that in the end I'm going to win this argument and you're going to lose it decisively. So how much you want to bet, retard? Anyway, he never, see again, so this is such a lie. He never paid the $50 on the bet I won. This is a fucking disgusting lie. I never made any agreement with this moron about any bet, about anything. It's just a fucking lie. It's disgusting he gets away with this horse shit. Show me the clip where I made a bet with you about anything, or whether I promised to pay somebody to do experiments completely in the shittiest, dirtiest, filthiest way possible. Yeah, no, I didn't do any of that. Predictably, he just lies that he didn't meet his, that I didn't meet his challenge. Well, how, in what way did you meet it? Show me. Show me where I made some challenge in some vague sense that any moron can glue, whatever, two cockroaches together and say I measured their voltage and yeah, the fat one has half the voltage. What the fuck are you talking about? Where did I make that agreement? He is absolutely massive. Insert insult of choice. So again, can you believe this weasel would try to convert this into some kind of thing where I somehow reneged on paying him his appropriate fee for doing his garbage experiments? That somehow I did make an agreement with the world. Go ahead, do a shitty experiment. Crash a Matchbox car into a cracker and I'll pay you $50. No, I'm not going to pay you anything for that. Amazing. I'm not the slightest bit afraid of him because he's the most cowardly, weak. So this is a guy who can't draw a lever on a board. He can't respond to a single one of these arguments I make. Not a single fucking one. So he won't explain in the physics girl example how you can deform something and not use any momentum. He won't explain that. He won't explain how this hydraulic experiment fails. How it's unreasonable to think there would be a 2-to-1 relationship between the two cylinders and the one cylinder. Yeah, a perfect relationship. Alright. God, what a fucking despicable hunk of shit. Alright, despicable person imaginable in the context of his pseudoscience. So who's doing the pseudoscience, right? He's making declarations that he has done what physicists for 350 years haven't done. Now, he hasn't done any experiment, I guess, where he claims it's 4 times the fuel. So we haven't seen the 4 times the spring compression or something experiment. But whatever. The irony is, I could have created these experiments if I had wanted to. I could have cheated. You're cheated by being stupid. Okay? Science is cheated when morons do this kind of, I'm not going to pay any attention to details. I'm not going to, who needs quick releases? Who needs to understand that you're not supposed to compress springs all the way? Who needs these little detailed pieces of information? I don't need any of that. I don't need to understand Galileo's ramps. I don't need to understand the 3-to-1 relationship. I don't have to understand that it's in the gravity only twice as long. I don't have to understand that it only travels twice the time. No, none of that means anything. I don't have to pay any attention to those details. That's all you're demonstrating. Because I accidentally discovered it is very easy to make the results twice as impressive. So he's just pointing out how, wow, you really shouldn't trust him. Because, yeah, he's basically pointing out how, yeah, I get all kinds of numbers. Just depend. I turn the screwdriver this way, I get one answer. I turn it that way, I get another answer. Just amazing. Against Gary's claims. So he's basically admitting that I get such various answers that I could get any answer you want. So you tell me what answer you want, and I'll do the experiment and produce your answer. He's admitting it right in front of us all. Yeah. By employing a lever which was just very slightly flexible. He has changed the lever, right? So he's going to redo the lever experiment because, yes, he did create free energy in his other experiment. So he's going to redo it so he doesn't do that anymore. So he gets his 1.4 result that he insists must be the truth. Yes, and so he's talking about these little defects you can take advantage of, and frankly, he's going to take advantage of them right in front of your faces. He's going to do it right in front of you. The experiment the first time didn't come out right, and he's going to show you how he can make it, force it to come out right. Okay, because it makes the one mass at the far end of the lever 2x from the fulcrum, further, I guess that is. The one mass at the far end of the, yes, go even faster than 2x the speed. Yeah. So somehow the bending of the lever is for free. So you use the same force, and somehow the lever bends for free and actually makes extra energy. So that's another one of Brozo's theories, that springs are the source of free energy. So anything springy will make lots of free energy. I mean, obviously, if a spring is pushing a lever and the lever bends, the bend had to come out of the spring's energy. It can't make more energy. So the fact that he could make it go even faster means that his regular experiment must be a little slower than it should be. More like 3x. So go ahead and show us that experiment, please. Show us the same spring compression creating 3x because you used a sloppy lever. Let's see that. Because it's realistically, well, no, it's changing it is the stop. So I guess I should draw that experiment just so you can understand. So I guess it would work because of the stop. Because you're bending the lever more and the stop doesn't know that. And so by the time you hit the stop, it will have released more energy. So I don't need to draw it yet. I don't think. But I suppose I might as well, for context, what experiment we're talking about now. Alright, so I have for 2 years been pointing out this lever argument because I figured this is game over. It should be logically understood by everybody that levers aren't making free energy, that theoretically I could make a lever and actually put a bullet on one side. I could put the recoil of the gun on the other side, and it would in fact make perfect sense. So the experiment is basically you take a lever, hopefully an even one, okay, not a catapult, alright, and you put a 2 mass here, and you do the experiment. So you compress the spring exactly the same much, you move this back, same spring compression, same force. Then you shoot a 2 mass object, it goes a velocity. Then you redo the experiment with a 1 mass twice the distance from the fulcrum, and it obviously goes faster. He says, okay, it absolutely only goes 0.4 faster. So if this has 10 velocities, this will only have 14 miles per hour. You'll only gain that little 0.4, and it'll leave behind that huge 0.6, right? Now, when he did the experiment, he did it on glass, which makes sense, less skidding. Okay, it's cue ball, billiard balls on glass, really very low friction. And he got a result of this was 10. This was 11. And this was 19 by his calculation. Okay, I'd argue by visually looking at it, this thing is going damn fast. It's obviously twice as fast, frankly. So it's clearly pretty much exactly what momentum would say, which was a 2-to-1 relationship in the velocities. So you've half the mass, twice the velocity, just like Professor Lewin says in the famous quote. Okay, the twice as massive object has to go half as fast. And that's the result. So he's going to redo the experiment because he doesn't like these numbers. 19 and 11, ooh, that looks bad. That looks too much like 2 to 1. So he's going to try to fuck it up to stop it doing that, to stop it being a confirmation of momentum. And he's going to try to conserve the kinetic energy and destroy the momentum. So he's going to basically prove non-conservation of momentum. He's going to prove that he doesn't have to conserve the momentum in the spring, the energy in the spring. Pathetic, really. Yeah, okay. And he's proud to do it. He's proud to break the experiment any way he can to force the result to come out the way physics says. Alright, so where was I? LEDs, okay. Water and, let's see. Okay. The irony is he could have faked it. Let's see. Because it bends further than it is meant to in the 2 to 1 scenario. Okay, so what he's talking about, see, what he did is put his stop on here so the balls would fly off the lever. Now, I don't know if he needed that, but that's what he did, right? I mean, theoretically, you really don't need the stop because that's not necessarily the same force then, because the lever could bend. So the idea is if the lever bends, that is when you pull it back, you put a springiness in it. Okay, I guess that would be the part that's where it's bending, is when you're pulling it back, it bends a little, and then it's going to shoot. I don't know if there would be actually a differential in the energy. I haven't studied that. If the bending is basically happening across the whole part of the, the center of the aluminum or whatever it is you're bending, that the spring effect would be the same for both. But who knows? I mean, it would be the same rule as the lever, that the further out you go, the more energy you get from the bending, more velocity, and the closer you are, the less velocity you get from the bending. But who knows? I don't know at this moment. Certainly something that could be reasoned out, no doubt. Shit. I gotta remember where I leave off before my eyes leave. I should take a note. Where was I? So it accelerated the one mass faster than 2x faster. So he's conceding he got some sort of 3x number, which is, quite amazing. Anyway, I mean, that's free momentum now. So he's created not only free kinetic energy, but a big pile of free momentum. And compressed the spring more than it is supposed to. Okay, so who knows what that means. It compressed the spring more than it is supposed to. I don't know how the bending of the lever could compress the spring more. So that doesn't make any sense. If I had intended to fashion as he falsely claims, I would have kept my first lever and showed that experiment. So he's not going to use the lever he used in the first experiment. Does that make any sense? I didn't see, nobody saw anything bending, but whatever. But that would have been dishonest of me. So I replaced it with a strong steel lever, and as well as a stop to prevent the lever going further than it was meant to. I don't know what that means, the further than it was meant to part. Why is there a further than is meant to part? The idea is you have the stop really at the point of maximum velocity. I mean, theoretically, there shouldn't be any more compression from the spring when you're at the level part. So when it's level, you bend it, you pushed into the spring. Now the spring is done pushing at this point. And so there really shouldn't be any issue of, I don't know whether, again, off the top of my head, I'm saying, do you really need to stop? Because the object should already be going its maximum velocity. So the lever shouldn't be able to keep, if the lever's still moving, it shouldn't be moving faster than the object that's already moving, that's already pushed. It's already giving it its maximum velocity, so it shouldn't be in contact with it anymore anyway. So I don't know. So you have to do the experiment with a stop and then without a stop, and then we can look at it and say, hey, yeah, there is a difference. But theoretically, there really shouldn't be a difference. Anyway, okay, and that's why I even wrote in large letters across the middle of the table in my published experiment. There's crap written all over your fucking published experiments. They're fucking eyesores. There's crap in the way. You fucking edit things so you see it for 4 seconds and then you jump cut to some other kind of bullshit. I mean, it's just horrible. New bar, meaning it was my second attempt with a stronger lever. Why do you even need this if you didn't show the first attempt, which could not flex and would stop dead against the stop screw? I would argue that yes, it's good to use a lever, okay, that is rigid. So yes, find one that's rigid. But you really shouldn't be pushing objects that are so taxing, that the lever can't handle it. In my latest version, I will publish ASAP. So far, not yet. I have used a very large block of copper to act as the stop. So why don't you just get rid of the stop and let's see the experiment without it, frankly. And although the lever is now aluminum, I don't know, is that good? So you move from steel to aluminum for unknown reasons. And he's using heavier weights, which is ironic, right? So he's moved to a lighter metal and is going to move heavier weights down. Does that sound like the right way to go? Or should be going the other way? The heavier the weight, the stronger the metal. Because the weight of steel would interfere with the results of this particular demonstration. So how could that possibly make any sense, right? I mean, it's a lever. And so that part of the experiment can't change, right? It's a perfectly balanced lever. You got a fulcrum in the middle. If I made it out of cement, I made it out of sawdust, balsa wood, it doesn't matter what I make the lever out of because the spring has to push the lever. In both cases, it's pushing exactly the same amount of lever. So whatever the weight of the lever is, it's going to be irrelevant to the experiment. Now, the only thing a heavier lever is going to mean is you might have more weight on the bearing. This is looking from above, okay, at the experiment. So you have to make a nice, so it's, you don't want a bearing that's pushing on too much weight. But, I mean, even that's probably pretty easy to, you can make a very big object and put it on a very small fulcrum and it will spin really easy. I mean, I showed the video of the guy moving the 5-ton rocks, by just putting a rock under the rocks. So, yeah, on a little bearing, the weight becomes kind of irrelevant to the motion this way and the motion this way. So, why would you make this argument? Because weight of steel would interfere with the results of this particular demonstration. How exactly would the weight of the lever change anything if the lever's balanced? So you could explain that part to me, because I don't see how that's possible. The heavy copper mass was critical. Why exactly would that be critical? To make sure the aluminum lever did not also flex. So I don't know how the fuck it could possibly change any of this flexing crap, because theoretically the objects have reached their maximum velocity at the parallel line. That's when the spring stops pushing. And how much flexing can there possibly be? How heavy a mass are you pushing, retard? Anyway, so we went from billiard balls to something insanely heavy, apparently. It may be metal and relatively strong, but I did once more accelerate the one mass too fast. So again, he was getting the wrong outcome until I took measures to make sure it gave a 2-to-1 result. I don't even know what, you don't want a 2-to-1 result, so I don't even understand that. When both masses were launched simultaneously. Right. So that means that they're both on the lever. So obviously the same force is pushing a different amount of total mass. So obviously the velocities would not be the same with both of them on the lever at the same time. But there will be a 2-to-1 relationship. There should be. So it's really bizarre that he's saying he was getting a 3-to-1 relationship. I mean, that's a really flexible lever, frankly. I mean, that's a lot of energy difference. So you got to wonder, about how credible that lever is. All right, that's a very important point to observe, or we get wrong results. So he's telling us, it's important, and I'm wondering, yes, and he's going to exploit it to his advantage. Anyway, dishonest results if we were to do that deliberately, exploiting that weakness. So I'd have to first see that weakness. How the fuck you're actually getting a 3-to-1 relationship. How you're actually making more energy. But whatever. Sometimes that would benefit Gary rather than me, but it would still be cheating. Whatever. Amazing bullshit there. Yeah, it would benefit Gary if you didn't fuck up with the experiment too much. Except that Gary would not object to whatever it took to get the results he wanted. I mean, it's not just about what I want. I want something that makes sense. And I'm just saying, until I see you do an experiment with some kind of credibility where you do this, I don't have to conserve the momentum thing, or you make things happen in the universe, you make heat, or you make things deform, and you don't use any momentum to do it. Yeah, I'm going to be skeptical until you show me a pretty good fucking experiment. It's also important to note, and this is the whole point of my last experiment due to be uploaded ASAP, so he says it again. He's going to do it as soon as possible. I already predicted it's going to be a piece of shit, okay? The video is going to be a piece of shit because his whole motivation is to make a correction for the fact that his first video basically did prove free energy, and he has to run away from that conclusion. It's important to note that when the same objects are launched separately, the 2-to-1 relationship collapses. So it's important to note that that's not what your first experiment showed at all. So that's absolute bullshit. Alright, the one mass no longer goes 2x the speed. It goes exactly 1.41 the speed. So he's saying he's completely destroyed the momentum, and he's conserved the kinetic energy. So it's exactly the opposite of what Professor Lewin said is the rule. That is, nature can fudge kinetic energy one way or the other, but nature can't finagle momentum. So he's saying exactly the opposite. Nature can destroy momentum, and it can, fudge it one way or the other, but nature can't finagle kinetic energy. So he's saying exactly the opposite of what Professor Lewin said is the rule, and yet is he making this video to Professor Lewin? No. Yeah, why not? You've broken their physics. Bravo, Brozo. You've shown how the conventional theory is crap. So why don't you go, assert your authority and show them where they've been misled by Professor Lewin. Alright, Gary needs to ask himself, how can the same experiment that just perfectly demonstrated the true 2-to-1 relationship when they are both launched together then somehow be flawed, as he is bound to claim, when it shows a perfect 4-to-1 relationship? So he's going to show us that he can make the experiment come out with either result. I'll do it this way, and I'll show free energy. I'll do it this way, and I'll show conservation of kinetic energy. So, isn't he just showing us that as an experimentalist, he's not to be trusted? All right. I mean, it's just amazing. Relationship when they are launched singly. Yes, the two experiments I compared were not. I didn't show the experiment where you're proving that the lever is a stick and it can't be bent. Oh, fuck. He will waffle. There's been no waffle, okay? I mean, I've overtly stated you are going to cheat the experiment. You are going to take advantage of some flaw you can create, some extra friction, some other kind of bullshit that you can create to fuck the fucking experiment, to force it to come out the way you want it. There's no waffle. He will waffle and accuse as usual. I'm predicting which will be the actual outcome, okay, is that you are going to produce an experiment of lower quality than your first experiment. But it will be just him being too weak to face the facts. Yeah, well, whatever, the real facts. So again, he says this video is going to have real authority. It's going to have real integrity, and you really could present it to Professor Lewin to prove to Professor Lewin that no, nature can finagle momentum. No problem at all. Fuck momentum. Kinetic energy rules. I mean, he's overtly doing that, and you fuckers will not hold him to account. You will not ask Brozo, why don't you present this brilliant piece of evidence to Professor Lewin so he quits lying in his fucking MIT lectures? I mean, save him the indignity of saying all these stupid things he's saying. Not his invented ones, endlessly reinvented and regurgitated. Like your fucking vomit experiments. Yeah, they're just farts and vomit. Okay. The reason it comes out a 4-to-1 is because, as the kinetic energy formula suggests, the same spring can only give the same amount of energy to each object separately. So again, that doesn't make any sense. Springs collect weight. So just explain to us how you're saying the spring is compressed more by your kinetic energy than the weight. I dropped something from 4 times the height. It only weighs twice as much. That's what the spring says. So obviously springs aren't measuring kinetic energy. They're measuring momentum. What an idiot. So they have the same joules when it's 4.1 large singly. So again, he's saying, fuck conservation of momentum. The spring does not conserve momentum. But they do not have the same momentum. Right, which means you destroyed the momentum of the force. The force, unlike what Newton said, twice the force, twice the velocity, nope, didn't happen. 1.4. i.e. 1.4 times 1 is not the same momentum as 1 times 2 mass launched separately. Yeah, we already know that 1.4 is not going to be conservation of momentum or logic, clearly. I agree. Okay, completely. But then you have to agree that you've just proven a fundamental law of physics, the conservation of momentum, the idea that you must conserve the momentum. That's exactly what Physics Girl said. You have to conserve the momentum. She said that. You're saying you don't have to. But anyway, but in the other scenario, both being launched off the lever at the same time, the 2-to-1 relationship is inevitable. Yeah, we're already. What he means is that when I put both objects on here at the same time and then use the spring, that this one has to move twice as fast, right? Because it's obviously twice the distance out here. This is twice the distance of this in the same time. Moving twice the distance in the same time means you have to have twice the velocity. But the simple argument is nothing changes when you launch them singly, because frankly the same relationship exists. The lever has to move the same. The amount it moves to move this, well, half the velocity is exactly the same movement here will take place when this one moves twice as fast. This one can't move twice as fast without this one moving some other amount. So if I move this 1.4, then this has to move slower too. And how could that possibly make sense? The spring just sees how much this weighs. This weighs 9 pounds, this weighs 9 pounds. That's all the spring can see. How does it know to give this 1.4? I mean, the question isn't that complicated. Could you just answer the fucking question? How does the goddamn spring know that you've tricked it by putting this half mass out here? How does it see through the trick? Oh, man, it's just amazing. Let's see. You can only go 2x faster, spring whatever, apportioning more of its finite amount of energy to the smaller, faster object. So again, he's just basically saying there's no conservation of momentum. So you can't say they now have the same momentum. What does that mean? I mean, maybe I'm in the wrong place here. So maybe, I mean, he keeps writing the same shit over and over again. He's got all these stupid capitals in here. So they have the same joules when it's 1.4 launched singly, but they do not have the same momentum, right? So that's just breaking a fundamental law of physics, i.e. 1. Okay, we already did that. But in the other scenario, both being launched off the lever at the same time, the 2-to-1 relationship is inevitable. I would argue to you that it's theoretically inevitable in the other case also. But anyway, so long as the lever does not flex and care is taken to ensure it stops dead when it meets the heavy mass, or say, well, it's not supposed to meet the mass, frankly. The mass is supposed to be against the lever throughout the whole motion. You're not whacking things. So again, maybe he's going back to hitting things instead of pushing things. Hitting is different than pushing. So I've already made that video. So yeah, maybe that's the catch he's going to use. He's going to smack the objects. He's not going to push them. He's going to smack them. Completely different experiment. You don't have any likelihood of getting all the energy into the object. The heavy mass will not, okay, get its portion of energy because the lever will bounce off of it. So bravo for fucking the experiment in a way I didn't even think you would resort to. So we know right there, that's the word, right? Okay, so that's a giveaway. Taken to ensure it stops dead when it meets the heavy mass. Oh, I guess what he's saying is his stop is a heavy mass. But again, why would that have anything to do with it? The lever stops dead. Who cares what the lever does? If the lever bounced, who cares? The objects are already launched. They're already going. Why do they care what the lever does after they're already going faster than the lever? I mean, that doesn't even make any sense. Well, anyway. Or say a screw to stop it from going too far. So again, what's too far? Exactly. Explain to me how it's too far. If the lever still has energy to push the thing with, why don't you let it keep pushing it? Now they have the same momentum. Again, more talk. They can't have the same momentum. You just said one's going 1.4. That's not the same momentum. 2m times 1 velocity, 2 velocity, 1m. But not the same energy. Yeah, exactly, retard. Which sounds confusing until we punch in some simple numbers and apply the KE formula. If they have the same momentum, they can't have the same energy. So that's just understood. Okay, the KE and the MV can't be equal when you're changing the mass. Anyway, then we realize the one mass can only go 2x faster if the spring or whatever is apportioning more of its finite amount of energy to the smaller, faster object, which doesn't make any sense. It's a weight. The spring can only produce the weight. It's countering a weight. You have a spring, you compress it, it's creating a pressure. The pressure is either more or less than the weight you're pushing. It has to be more, it pushes the weight. It's really, it's not complicated, frankly. So anyway, I don't know what all that gibberish is basically saying. He's saying that somehow it makes sense to him, okay, that he's going to destroy the momentum. Okay. Gary then jumps to the wrong conclusion. It means there has been a gain in energy. LOL, he says. Well, the spring is capable of producing a certain amount of joules of energy, and you're producing two different outcomes. So in one case you produce 100 joules, in the other case you produce 200. Well, then you have to explain where in the one case you lost 100 joules. because the spring is producing the same amount of force. Oh, amazing. No, the speed in this experiment are both much slower than when the objects are launched separately. Yes, we already know that. So what? It's much slower only because you're basically pushing 2 9-pound weights instead of 1 9-pound weights. From the spring's perspective, you're pushing 2 9-pound weights if they were 9 pounds each. Obviously, in the other experiment, it's only pushing the 1 9 pounds. You put both of them on the lever at the same time, you're pushing 18 pounds. Duh, of course they're both going to go slower. Duh. Alright, anyway. He can't wrap his head around that. I mean, you know, too silly. And I concede it can be confusing if a person never shuts up long enough to think it through. Think what through? There's nothing to think through. We're not comparing the two experiments. We're not comparing putting both of them on and doing the experiment and then comparing that to putting one of them on. We're just saying, go ahead, put one on at a time, put the same amount of energy in, and let's see what the results are. Alright, I mean, clearly in the other experiment you have something to explain. I mean, when they're both on the lever, you're saying one of them clearly gets twice as much energy as the others. So in spite of the fact that your own fans argue that the lighter object has more inertia, the lighter object gets more energy from the lever than the heavier object does. So I mean, you're already conceding that, but you won't explain it to me. You won't explain how the lever did that. How did the lever give this object twice as much and this object only 1 unit of energy? How does it know to do that? He can't wrap his head around that, and I concede it can't. Well, anyway. So yeah, best of luck with your work. Yeah, whatever. Just be mindful of the pitfalls to save time in the long run, having to do experiments again. Well, I think he's already aware of that. He's done like 4 experiments and every one of them was a piece of shit. So I think he already knows pitfalling. He's done a lot of pitfalling. A mistake we all make when we are in a hurry. That has nothing to do with being in a hurry. You do 0 research and you do 0 contemplating of the physics implications of your bullshit statements. Your statements are unaccountable crap. You are in fact saying you're not obligated to conserve momentum, and you don't have to explain where the energy went. You can destroy it, okay? Absolutely. Alright, I made a different mistake in a hurry to demonstrate all of this with pool balls and half pool balls launched off a lever. So he's saying he did it in a hurry and it was a shitty experiment, blah blah blah. And why? Because yes, his outcome validates my statements, not his. Okay. My mistake was that the half pool ball was too light. Okay. It skidded. Now, it is a fact, okay? I observed that. I pointed it out. Maybe he didn't notice it until I pointed it out, but yes. Yeah, you can clearly see that the one billiard ball rotates and the other billiard ball does not rotate. But that can be understood. It's happening for a lot of reasons. And we don't have, great data on why something skids and why something doesn't. And on a glass surface, you could almost argue it couldn't possibly make much difference. But anyway, we'll just... when the lever... See, the whole thing was, as I pointed out, what we don't see in his video, because he always films them so shitty and he never explains how anything works, we don't even see the spring in his video. Barely see it. We don't see whether this lever is hitting the center of mass of the billiard balls. We don't even know that's what he's actually hitting, the center of mass. You really have to hit their center of mass if you're going to do the experiment correctly. Alright. Was so light it skidded when the lever tried to accelerate too fast for it to grip the surface and rotate. So there's no advantage to obliging things to rotate. So that's not something to say, gee, rotation is so essential. It is preferable to have them both do the same thing. But I would argue in this case, it really couldn't have made a difference. All right. That losses of rotation and loss of contact with the surface meant it went faster than it should have done. It went a lot faster. So there's no way you could account for it as being, oh, it really should have been tremendously slowed down by rotating. The rotation of the heavier ball was almost insignificant in terms of if you did actually measure its rotational energy, it would be almost nothing. The speed of the full mass, the pool ball launched in the usual position on the lever. The usual? I didn't think there was a usual position. 1x distance from the fulcrum. That gave Gary false hope. I don't have any false hopes, frankly. As I pointed out, I have every expectation you will do whatever you have to force the results to confirm your crap. And you can see, look, I've pointed this out before, but he's done a ton of other experiments and he never shows us. You know, he did all kinds of radar experiments, never showed all kinds of experiments because they didn't come out the way he wanted them to. All right. Because he again jumped to the wrong conclusion that skidding implied it was subject to more friction. What I stated overtly is that if the skidding is being caused by backspin, that is, you introduced energy a little bit too low and are causing a negative rotation, that would slow the ball down, in fact. Thinking that if it hadn't skidded, it would have gone 2x faster. So again, he's saying it mattered. I didn't realize he had done the experiment on glass. I mean, pool balls on glass, realistically, there can't be all that much friction, especially when the distances are incredibly small. All right, he was so wrong. Skidding made it go too fast, not too slow. Well, you won't prove that because you won't do the same experiment, okay, again, and demonstrate that. All right, hence the 1 to 6.9 result, which he keeps wrongly bragging supports him, only quoting one of the results. I'm just saying, yes, I'm saying they all, generally speaking, any observer could look at them and say, bingo, that's twice the speed. So you want to pretend it's only 0.69 the speed? I'm going to say, fuck you, that's idiotic. That's your measurement problem. All right. Not the final average, he keeps quoting. You conceded one of those experiments in your group of experiments was complete shit because you didn't launch it properly. So did you keep that in the results, the broken experiment? Probably. And saying that is as good as 2 to 1. I'm saying 19 to 11 is as good as 2 to 1 in my book, considering Brozosian error. Well, to his empty-headed fans, I can see that why they agree with such simplistic nonsense. That actually works out to 1.72 to 1 because he ignored the average results, bring it down. It's the same thing over and over again. So again, he's just trying to deny what is obvious in the experiment, that the half as massive ball did in fact travel twice as fast. I feel guilty for accidentally giving him the false ammunition. It's my fault. So again, he's going to now prove that you don't have to conserve momentum. See, his first experiment was a mess because he conserved the momentum. So now he's going to prove you don't have to conserve momentum. And that's why I'm putting the matter right. And he's going to prove there is no conservation of momentum. Nature can not finagle kinetic energy. Nature can fudge momentum one way or the other, but it cannot finagle kinetic energy. That's the new mantra. He's proven it. By doing the experiment more carefully, using heavier masses and a less slippery surface. So does that sound like a better idea? Heavier, bending levers more, and more friction. So somehow more friction will certainly help the experiment. I guess glass in the first experiment, thinking it would be perfect, flawless surface. Yeah, that's right. I never thought about skidding. Whoops, my bad. So again, he thinks that the less friction he has in the experiment Well, that's bad. I don't want less friction. Okay. Now Gary, being dishonest so and so, exploits my mistake by wrong interpretation of what it meant. Yeah, what it meant was, first, it proves you can't do experiments worth shit, and second, it proved that you really are trying to prove the non-conservation of momentum, because you got conservation of momentum and you said that was a wrong result. Okay. So I'm pleased to confirm the one math does go exactly at the speed the kinetic energy formula suggests. So he's going to destroy the momentum. So that's his new perfect experiment. It will prove there is no conservation of momentum required. So I hereby apologize to everyone for causing this confusion. We all make mistakes. So again, this is just, finally this should be the final nail in the coffin of Brozo's credibility. Because here he is basically just saying, look, the first experiment produced a result I don't like. Here's another one, another variation to do it the way we want it to come out, right, guys? So he's basically going to just show you how I'll fuck it to make the result come out the way we need it to. All right. The only good thing about Gary is his insistence is that whatever that is that he was the one who pointed out the skidding. I never noticed or realized the significance. Yes, exactly. You people don't notice anything. Small things can make such a big difference to an experiment. Well, in this case, I think it's kind of idiotic to think the amount of rotation in the twice as heavy ball was in any way accounts for 0.6 of the energy. He's right about that much, but he always interprets whatever small things small things like quick releases as important. Yes, that's what I do. All right, as swinging it in his favor if corrected, and he's always so wrong. No, all your experiments have been wrong, and I have pointed out the gigantic defects in all of them. All right, he's not a man, he's a mouse, whatever. You're a lying piece of pus. Okay. I used to be a bit afraid of him insulting me. I don't know why that would... I can't even relate to that concept, but whatever, which is his plan. Again, no, my desire is that you just go away because you're just a noisemaker. You're just a stupid irritant. If you didn't exist, you couldn't create this little fake theater of morons who can get away with just spouting this unaccountable crap. I mean, your people can't stay on the subject. You endorse people making up complete fairy stories. They can't accurately describe a single one of my videos. I mean, it's disgusting what you let take place in your comment section. It doesn't work on me anymore. Yeah, because, frankly, you're going to lose and you already know it, I think. Okay, but anyway, I laugh when he calls me all the names under the sun. One day you will too. Yes, I'll make sure of that. Okay, you will be synonymous with urinal. Okay, that's what you deserve. A picture of you should show up in the dictionary. So fuck you. Anyway, so Mindless Marbles apparently made some comment that we didn't get to see. How disappointing. Alright, so that was a long pile of crap. Alright, so let's see what the other morons have to say. Sorry. Everybody does fall short. So just that's it. Hello. Okay, well that's not very useful. So I don't even know if I'll bother popping the chat out, right? It's just not enough of it to even bother with. So we'll just move it over here or something. Blah, 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 and see if anything happens. But it doesn't look like it. Alright, so I'll give you a couple of minutes, and then I'll be on my way. And such. see, what time is it? Oh, yeah, we're right on the 1:30 mark anyway. So it is funny that Brozo complains about long videos, and yet he types these very long comments. And he doesn't see the comparison, that if he had to make all of the points he made in that comment in a video, it would take a while. But he is horribly redundant. I mean, keeps saying the same shit over and over again in different size text. Like that's somehow going to make a difference. No, it says 10 viewers. You better comment. Come on, you can do it. Got to be able to say something. Is Brozo really saying there's no conservation of momentum? Yeah, he's really saying it. Well, why doesn't he take that argument to other physicists who are saying otherwise? Because this isn't about physics. It's not about science to Brozo. It's not about the truth. It's just about him being a pain in my ass. That's his only function, is to get in the way. Alrighty then. So, till the next time, and is that a comment? Yeah, there we are. I have nothing to add, but great work, Gary. Well, love these videos. Well, I don't know if they're lovable, but they could be likable. Hint, hint. Such a funny concept. Internet. So bad. But I think I've made the point, right? I mean, the physics girl video is just, gibberish. I conserved the momentum, but I did a bunch of work, with the non-momentum I used. And then Brozo's basically saying the same thing. Somehow I can extract more energy out of the spring. Well, in his case, less energy, right? 1.4, I can stop the spring from doing what it perfectly does when it oscillates, right? The lever perfectly oscillates with the two mass in this position, the one mass all the way out, right? Perfectly oscillates. And somehow we're supposed to believe if I just put enough energy in to make the things lift off, just a little bit of extra energy, and so they pop off the lever, that somehow that ratio won't exist anymore. The thing moving twice as fast will know, I have to go 1.4, I have to stop moving fast. It's just so illogical. And again, for 2 years I've been saying, just do it. People who say I'm wrong, just explain it, right? These were really simple drawings. Just draw it and explain how the forces and the energy work. Explain how you don't have to conserve the momentum. Explain how the bullet has 2,000 joules and the gun recoil only has 2. Explain how the explosive knew to do that somehow. That in spite of what Newton says, equal and opposite, somehow, no, it doesn't have anything to do with that. Okay, so I will tunnel off and such. So, till the next time, and such, and so forth, and whatnot. Appreciate your attention, I guess, right? Because you didn't do much commenting. But anyway, till the next time and such.